In the bone-chilling cold of -1 degree, the Space Shuttle Challenger stood proudly. The spacecraft consisted of a prominent primary brown fuel tank holding liquid oxygen and liquid nitrogen. It was flanked by solid rocket boosters on either side, with the Challenger Space Shuttle positioned in the center. It was poised to launch in a mere 10 seconds.
T-minus 10, 9, 8, 7.
At T-minus 6.6 seconds, all three engines were fired.
1, 0.
The right and left side solid boosters were activated and the Challenger Space Shuttle began to ascend. At the time, a small smoke leaked from a joint in the right wing. At T+2 seconds, the leakage stopped temporarily. At T+36 seconds, when flying at 3000 meters, the wind speed was very high. The computer gave some commands to the engine to keep it from going off course due to the wind. At T+58 seconds, Challenger reached its top speed. By then the smoke leakage could be seen clearly. At T+72 seconds, the right booster got detached from the primary fuel tank. Now, only the bottom link held the spacecraft to the primary cell. At T+73.125 seconds, the liquid hydrogen cell in the fuel tank ruptured and crashed into the liquid oxygen cell. At T+73.162 seconds, the spacecraft started disintegrating. The shuttle crashed into the Atlantic Ocean nearby, killing 7 people on board, including 2 women. Hi, I'm Hilal Alam from ALZEBRA. Let us see how a precautionary modification led to the historical disaster. It was Challenger's 10th mission. It had previously completed 9 successful journeys into the space since their first voyage in 1983. In response to the accident, a committee called the Rogers Commission was established to conduct the investigation. It included the participation of the renowned Nobel Prize scientist Sir Richard Feynman. The commission conducted a comprehensive investigation with a specific focus on the design aspects. Their findings revealed a crucial issue related to a small pod that had been misunderstood or misinterpreted during a design alteration. Following the Space Shuttle Columbia mission in 1979, NASA embarked on the development of the Space Shuttle Challenger. The design of the Challenger was intended to feature 2 solid fuel boosters positioned around a massive tank containing liquid hydrogen and liquid oxygen. The designers analyzed various booster models and ultimately chose the Titan III as a basis for the Challenger's booster design. The Titan III, ranging from 3A to 3E solid rocket boosters, had a remarkable track record as the most successful boosters from 1960 to 1980s. They were responsible for launching the Polar satellite and other missions for NASA. The Titan III spacecraft held the distinction of being the first to transport Voyager to Jupiter and Saturn, as well as Viking to Mars. Drawing inspiration from and designed with elements based on Titan III, the Challengers each booster consisted of 4 cylinders. These cylinders were interconnected using O-rings, which were positioned at the junction of the tank and clevis, ensuring a secure connection. The presence of O-rings at the tank and clevis junction in the booster design served the purpose of preventing the escape of combustion gas from inside the booster through the joint. While the Titan III had a single O-ring between the interconnectors, the designers of the Challenger opted for an additional backup O-ring to enhance safety. This modification could be seen as a precautionary measure, but it backfired heavily. After putting in use, it had completed 9 successful missions. The 10th mission, originally scheduled for launch on January 22nd, the Challenger's liftoff was repeatedly delayed due to adverse weather conditions. It was rescheduled multiple times, with the subsequent dates set for January 23, 24, 25, 26 and 27. Eventually, the decision was made to proceed with the launch to be on January 28th. The launcher was manufactured by Morton Thiokol. On the evening of January 27, 1986, the official from Thiokol reached out to NASA and recommended once again postponing the shuttle mission. They expressed the concern regarding the performance of O-ring in low temperatures. The O-ring had been tested to operate effectively up to 12 degrees Celsius. and it was stated that if the temperature dropped below that, the O-ring would encounter issues. Specifically, at the current temperature of -8 degrees Celsius, it was warned that O-ring would not function properly and could freeze. However, when NASA requested experimental evidence to support the concern raised by Thiokol officials, they were unable to provide the necessary data. Despite this, Thiokol recommended at least postponing the launch until the afternoon of the 28th, when the temperature would have risen slightly to 12 degrees Celsius. However, NASA did not agree to further delay the mission.
T-minus 10, 9, 8, 7.
At T-minus 6.6 seconds, all three engines were fired.
1, 0.
The right and left side solid boosters were activated and the Challenger space shuttle began to ascend. At that time, there was a small leakage from a joint in the right wing. Due to the freezing condition, the lower base O-ring in the Challenger's configuration functioned as a pivot point. This caused the backup O-ring at the top to experience slight flexing. As the backup O-ring moved away from its original position, a small gap was created between the components. This resulted in a smoke leak in the right wing of the booster. At T+2 seconds, the leakage stopped temporarily. Because the solid fuel shifted slightly downward, it exerted pressure and compressed the gap, effectively temporarily sealing the leak. At T+36 seconds, when flying at 3000 meters, the wind speed was very high. The computer gave some commands to the engine to keep it from going off course due to the wind. During that moment, the backup O-ring, which had been previously exposed to the small leak, experienced a significant displacement. As a result, the pressure inside the booster decreased significantly. At T+58 seconds, Challenger reached its top speed. By then, the smoke leakage could be seen clearly. At T+72 seconds, the right booster got detached from the primary fuel tank. Now, only the bottom link held the spacecraft to the primary cell. At T+73.125 seconds, the liquid hydrogen cell in the fuel tank ruptured and crashed into the liquid oxygen cell. At T+73.162 seconds, the spacecraft started disintegrating. The shuttle crashed into the Atlantic Ocean nearby, killing 7 people on board, including 2 women. During the design phase of the spacecraft, certain NASA engineers raised concern multiple times, stating that the inclusion of a second O-ring was unnecessary. In an effort to prioritize safety in the design, they went beyond intended scope. Interestingly, there was even a consideration to include third O-ring, but ultimately the decision was made to proceed with 2. Even during the previous mission, it was discovered that the O-ring had experienced wear and tear, but this information was not communicated to higher authorities. When the Commission tabled the report, Richard Feynman, in a lively demonstration, showcased that under freezing conditions, the O-ring lacked necessary flexibilities to effectively prevent gas leakage. After the accident, modifications were implemented to improve the safety of solid booster rockets. One such modification involved implementing a design change to cover the O-ring on clevis to prevent deflection. This adjustment aimed to enhance the overall safety and reliability of the rockets. With this, I sign off and we will meet in the next video. Till then, goodbye.